Hello, hi everyone. My name is Shaman Thiraman from CSEB section batch 26, and this is the continued extended video of how annotation data is collected and done and collected and implemented in the model. I might be very sure and pretty sure that Saru might have explained the architecture and the running of the code along with the implementation of writing the code in Google Colab. And after you're done with the major procedure, the first important task of writing the code, you head towards the second important vital task, which is to collect the data set. Okay, what is a data set? Data set is a collection of images. See, it not necessarily be images. It might be a text or a raw form. But since we're dealing with the face recognition system, we need to collect the images or capture the images of people for um, for implementing and training the model. So here we are. We have collected the sample images from various people in our class with multiple angles and dimension and and lighting conditions in different phones, mobile phones and cameras with different megapixels so that we reduce the noise effect so that the images won't tamper with the model and provide a greater accuracy and makes a statistical comparison and come with the predictions. So yeah, this is the data set and this is the sample data folder that I made for demonstration. Okay, so you might be wondering what on earth is annotation, and I'm very sure that most of you guys might not be familiar with the jargon called annotation. Annotation is, in a layman's terminology, is something that you call it procedure of bounding regions in an image and classify it into different objects and feed it into the AI/ML model and train it so that when you provide it with a test image, the model is gonna look for something that is similar with the annotated region, compare it, and give you the results and the desired information that you're looking for. Annotation can be done in multiple apps and APKs and websites available in the browser, but I personally recommend you all to use RoboFlow, not that I'm promoting it, but that we are making the task easier by reducing the time that you're gonna spare on creating separate folders, which can be done easily, but it is a very tedious job and a time consuming task. So just click on just type search for RoboFlow in your browser and it'll lead you to this website and sign in. And after you're done with the signing in part, it's gonna lead you to a interface looking similar to this. So you need to click on add workspace and create a new workspace. So after the creation of the workspace is done, you need to upload the images. You click on academy because we're dealing with a school project that is an engineering project, so RoboFlow won't charge any cost for you. I'm just deleting this very workspace. And I'm going to demonstrate you with an already existing workspace which I have and created. So we'll go to this, click on create new project, and the project type is going to be an object detection, which is we are bounding boxes. And what are we detecting? We are detecting people. and the project name is, let's set it as attendance, and this is the license where you set by default and create a public project. Now upload the folder that you've created. In my case it is a sample data folder. Upload them and hit on save and continue, and let's wait for the images to get uploaded. After they're done, assign the images to the labelers that you had invited in the part where you were creating the project. In my case, this is some random email ID that I had given. I don't want that person to do the task for me, so I'm just gonna assign it to myself, and then we're gonna start our job of annotating. Let's click on start annotating. Have the bounding box tool. Just bound the box over the image. This is me here, so I'm gonna classify myself into a class where this very bounded region is gonna be saved as Shamant. Out of this very image, this region is gonna be marked or annotated as Shamant, which is me. So we're gonna do the same, carry out the similar procedure for every other person. You're basically creating new classes when you deal with new people. Just continue the same procedure. Bound the box to a roughly estimated dimension. And now since we have two Shantanus in the image, we don't need to add a new class. We're just gonna click on the Shantanu that's present, and we're done with the task of annotation. Just go to back and add these images to the data set. And the magic of why I was enforcing you all to use Overflow is that it automatically splits the data images into train, valid, and test in the ratio of 7:2:1, and it's gonna reduce a lot of time for you. And the data set is uploaded and created, so we're gonna head to generate. What is this generating new version gonna do? I'm gonna explain it in the further part of the video. This is pre-processing part. You can auto orient them and change or edit the resolution and make any resizes. Since we have set the model in 640 to 640 dimension, I'm not gonna alter any changes, so I'm gonna click on proceed, and this is the augmentation part. Augmentation part is basically the rotation, changes in the color, so I don't want any of the stuff, and hit on generate. Yeah, after we're done with this, we have a train with TurboFlow option. Most of the people are gonna use this, and you can if you're not working on a project for your company or your school project, then you can showcase this to your friends or your family using this train with TurboFlow, and you don't need to implement the code which Saurabh had explained in this very part, and you can directly show this, but we are not going to do that. We are going to write the own code because yeah, you can learn some fun stuff and gain some knowledge. Yeah, you can custom train and upload, so this you can directly get the snippet right from here and tag it in your Google Colab. But I'm going to show you the interior parts of the data set, so I'll have to download the zip folder to my computer. Yeah, this is gonna be saved now. After the zip folder is downloaded, When we click on that, we have separated test folder which has images of the test images that are tag classified. Come back, and for that very image we have the labelings as well, which are the coordinates of the bounded region. So these are the coordinates. This is basically the xw width, x height, y width, and y height. So the magic that Overflow does is that it will separate it into different test, train, and valid folders along with the necessary data set extensions and YAML source files, which consume a lot of time if you start doing it separately on your own. And it's not recommendable because uh, the implementation of code is the serious and the major implementation code is in this part. So we're gonna directly use that very part into our coding region by mounting this in the Google Drive. First, we need to upload the contents of the zip file into our Google Drive, which I've already done so just click on this. So the Google Colab will request for mounting the Google Drive. Run the cell and mount your Google Drive inside the Google Colab. Now go to my drive. There I've created another data set folder which has all the test, train, and valid images. And since you need this very extension, that is the data YAML extension, just copy this path and follow the procedures that serve as shown. And this is the option for running the cell for implementing the model. It's gonna take hours, so you can refer Saurabh's video for training the model and running it and using the test images. So here I complete my part of showing you the procedure of how annotation is done and the collection of data set is done, and how you can use RoboFlow to reduce your task and time to directly export the images into the website and then annotate it for free and access or export the data back to the model that you are working on. So here we have some errors with regards to the last part, which we're going to update it soon. We are planning on implementing the FaceNet repository and TensorFlow and PyTorch for face recognition, because Yolo is basically an algorithm model which is used for object detection. It doesn't mean that we cannot do face detection, but the accuracy is less when a large number of people are present in a single image, and the detection becomes really hard. So we're going to implement the model and come out with the upgrades very soon as possible. So thanks a lot. Thanks for watching. Thank you.